I am here, I am there, I am everywhere. We all encounter various forms of fungi in our day-to-day lives. But did you know that when manipulated, the root-like structure of a fungus called mycelium may help address environmental and public health concerns? Air quality is a major concern in the 21st century. Between wildfire smoke, industrial emissions, and vehicle exhaust, it's increasingly difficult keeping poor air quality out of the home. Ironically, the same devices designed to filter out poor indoor air quality release harmful emissions during their manufacturing stage that further pollute the air. That's why we developed Microfilter, an air filter developed from Mycelium. It's designed to replace traditional petroleum-based MERV filters for standard HVAC systems in the home. Our product addresses Sustainable Development Goals 9, 11, 12, and 13. We designed our product for in-home use, so our audience includes homeowners and apartment dwellers, essentially anyone that regularly changes air filters in their living space. But how do we arrive from mycelium to air filters? First of all, we are an interdisciplinary group of students from UC Davis. We diligently researched the properties of mycelium and its different applications, pulling information from researchers around the world. After conducting research, we thought that we could use these mycelium cultures, which are stored in these jars, to mimic the structure of a MERV filter. We developed two main strategies for controlling the structure and shape of our mycelium. Our first experiment takes place in these agar petri dishes. We're experimenting with these thin sheets of fabric to determine whether or not they can provide some structural integrity for our filter. We want the mycelium to grow through the fabric, binding the mycelium to the fabric, but we don't want it to grow into the agar, which is going to rest on the bottom of the petri dish. We autoclave the fabric to prevent mold from forming. We were a bit concerned about the porosity of the mycelium, so we had an idea to drip wax over parts of the fabric. We were hoping that the mycelium would not consume the wax, leaving holes for air to pass through in the air filter. We originally thought that this metal tool would be great for adhering the wax to the fabric. However, the wax just hardened way too quickly. We tried to heat the tool up, thinking that would help, but it didn't really work either. We found this thin metal tool around the lab that was perfect for adhering the wax to the fabric. We're not really applying the wax in any specific pattern, just straight lines for now, but we're considering other designs for the future, including ununiform splatters of wax and also a more grid-like structure. At this stage, we're honestly more interested in determining whether or not the mycelium will eat the wax. After the wax dried, we place the fabric onto our petri dishes with agar on the bottom. Next, we inoculated the plates with mycelium. Our other experimentation, though, is completely different. We're experimenting with biofoam. The purpose of the biofoam is to observe whether or not we can get the mycelium to grow in the exact shape that we want it to. The idea is that the mycelium will eat the biofoam, leaving behind a similar structure that the biofoam left. Here's the straw-based biofoam and the regular biofoam. The white biofoam is a mixture of water, paper, and a surfactant. The straw biofoam is a mixture of straw, cornmeal, and a surfactant. For both biofoams, we just mix all of the materials together in a blender. After blending, we use this contraption to separate the liquids from the solids. We're injecting the liquid mycelium into the straw biofoam to observe how it eats it.